All right, so one of the colligative properties that you're going to see in class is we're going to talk about boiling point elevation. And that is the temperature difference between the boiling point of a solution and that of a pure solvent. And as you can probably guess from the title, it's actually going to increase from the solvent to the solution. The solution is going to have a higher boiling point than the solvent. And why is that? Let's define boiling point first. Boiling point is when vapor pressure of whatever substance you're dealing with is going to equal the atmospheric pressure of the pressure around it. Okay, great. So let's say we have a pure solvent. Let's say we have a beaker of water. We know that at the surface of water, those particles are going to escape into vapor, back and forth, and they're going to have some sort of pressure up here. And as we heat the substance, that pressure is going to rise due to kinetic energy increasing, and it's going to eventually reach the atmospheric pressure and then boil. Okay? So let's go over to a solution. Let's say we put something in it, let's salt, sugar, whatever your solute may be. And to make that solute actually dissolve, those water molecules are going to surround it. So those water molecules are actually really attracted to the solute that's in the solution. So what's going to happen is they'd rather be around these dots or these solute particles than escaping into vapor. So they're already going to start off at a lower vapor pressure. So they actually have to go increase kinetic energy a lot more to reach that vapor pressure to equal the atmospheric pressure because they're already starting at a lower place. So that temperature is going to have to be a lot higher, or depending on what the solvent is, to reach that atmospheric pressure and then boil. Okay, so let's talk about the different solvents and how the solutes are actually affected by them. So let's talk about water. We know water boils at 100 degrees Celsius, and it's found for every molal of solute that you put in there, it's going to increase the temperature, the boiling point temperature, by 0.512 degrees Celsius. Benzene boils at 80.1 degrees Celsius, and every molal or every mole per kilogram of benzene you put in is going to raise the temperature to 0.53 degrees Celsius, or boiling point temperature that much, and so on and so forth. So basically, if we put this in a nutshell, we have a formula here that's the boiling point elevation formula, and this is the change in temperature of the boiling point. That delta T is going to be the change in temperature times that constant that you see for every molal, that's the amount of degrees Celsius is going to increase, times the molal, the molality, which is the moles of solute divided by the kilograms of the solvent, and we're going to multiply it by the Van Hoff factor, or how much it's actually dividing up. Remember, electrolytes actually dissolve and separate themselves in water. So if you have 1 molal of, let's say, NaCl, you're actually going to have 2 molals of particles. So that is what we call a Van Hoff factor. So let's actually look at that in real life. It says, what is the new boiling point of a 0.029 molal of an NaCl solution? Okay, so we put some salt in water, and we want to know the new boiling point of this water. So we can just look at our formula and say our change in temperature is going to equal the constant. And now we're dealing with water because we know it's an aqueous solution, so our solvent is going to be water. So we're going to look at our table, and we know for every molal it's going to raise 0.512 degrees Celsius. That's what I'm going to say, 0.512 degrees Celsius per molal. We know our molality is 0.029. And our Van Hoff factor is going to be 2, because for every molal of this, it's going to actually break up. For every 1 mole of NaCl, it's going to break up into 2 moles of particles. So our Van Hoff factor in this case is going to be 2. Okay? So we multiply all of these together, and we should get 0.030 degrees Celsius. This is not our new boiling point. This is just a change in boiling point. So our new boiling point is 100. Our original boiling point was 100 degrees Celsius. It's going to change or increase, because we know it's elevating, by 0.030 degrees Celsius. And so our new boiling point is 100.030 degrees Celsius. Is our new boiling point of this solution. Okay? And this is why you can think about when you're cooking and you're throwing some salt into a pot of water. Not only are you adding it for flavor, you're actually increasing the boiling point of that water. So when you're dealing with, like, let's say pasta, you actually can cook pasta a little bit faster because your boiling point is actually a little bit higher than 100 degrees Celsius, and you can cook it at something a little bit higher. If you put the more salt in, the higher the temperature is going to be. But don't put too much salt in there, because then it'll be over salted and over flavored. But either way, that is boiling point elevation.